Good morning, students. This is a continuation of recap of Unit 2, that is Part 2 recap. What is DOE? Design of experiments. Design of experiments is a systematic approach to experimentation that allows engineers and scientists to study the effect of multiple variables on a process efficiently. So what does it mean? So when for whatever the process we need to optimize, so obviously we have independent variables and dependent variables. We need to make sure at one particular point of data this is synchronized to get a optimized point. It need not be a one synchronized point, it may be a multiple synchronized point. Please try to understand the concept. So, design of experiments will help you to systematic approach to experimentation that allows engineers and scientists to study the effect of multiple variables on a process efficiently. Why we need to study? Because we want to find the optimized point. Instead of changing one factor at a time, design of experiments enables the study of interaction between the multiple variables, leading to optimized process condition, improved quality, and reduced experimental cost. So what do you mean by one factor at a time? So one factor at a time, I already told you while covering this syllabus. Okay, so that means you are changing only one independent variable, not many. So if in a multivariate analysis, the equation, the dependent variable is a function of multiple variables. So if you change the multiple variables, what would be the effect on the dependent variable? I mean the response. Okay, so that's what that we could be able to see in by using a design of experiments. So the design of experiments embedded with a statistical tool, okay, and then it will help you to find the optimized point, and also it will tell you how the variables have been interacting with each other, whether there is a response, the response is changing because of the interaction between the multiple factors. Hope you understood what I am trying to say. And coming to the key principles of design of experiments, there are multiple principles are there. One is the multiple applications are there by using a design of experiments. The key principles are factorial design, randomization, replication, blocking, and response surface methodology. So mostly engineers we will use the response surface methodology because used for the optimization by modeling the responses over a range of conditions. So when we need to go for factorial design, okay, investigate multiple factors simultaneously. In that case, we can go for factorial design. What is randomization? Ensures that results are not biased due to the external variables. So the results should not be biased because of the noise level or external variables which is not considered in the equation, that should not affect the things. Ensure the results are not biased. Replication. So repeating experiments improves statistical reliability. Blocking reduces variability by grouping similar experimental conditions. Coming to an example for design of experiments. Okay, let's say we have a reaction temperature. So we have here they have taken three factors and they have a three level for each factor. That means reaction temperature, catalyst concentration, and agitation speed are considered to be a three factors on the what is called it. Obviously they will try to find the maximum yield of a batch reactor. Okay, so the independent variables are these three and dependent variable is maximum yield. So for each variable they have three levels. One is minimum, maximum, and the middle range. So what is the reaction temperature they keep? They didn't mention here the reaction temperature. Let's assume is a 70, 80 or 90 or a 50, 100 and middle value is medium value is 75. Okay, so if that would be the case, so it will, the design of experiments automatically have taken the variables, that means different rate between the minimum to maximum and also the middle value. So it will design the experiments. So number of experiments that is required based on the types of design of experiments. So in design of experiments, we have a box bracket method, central composite design, okay, D design, lot of under the design of experiments we have a lot of subcategories. Okay, so when we need to go that different methodologies of design of experiments, I'll tell you. Okay, while recapping because this we already have studied, right? So coming to the design of experiments, a factorial design is used to study the effect of temperature, catalyst concentration and agitation speed on reaction yield. So what is the interaction effect between the temperature and catalyst? Response surface methodology is applied to find the optimal condition, underline the word, to find the optimal condition for maximum yield. So the ultimate aim of dependent variable supposed to be higher, when so that in such a way that we need to make and identify the point of independent variable, okay, so that the response supposed to be higher. By applying the design of experiments, an optimal reaction temperature of 70 degrees Celsius, catalyst concentration of 1.2% and agitation speed of 250 rpm is found to be maximum yield. So they have fixed the temperature, let's say 70 to 100, the middle value let it be 85. So this is a three range, but the system, the design of experiments will give you different number of experiments. So it may take the middle, between the middle value and maximum value, and it will give you, please run the experiment only for this research framework. Okay, that means number of experiments that need to be carried out by this particular independent variable. So it will tell you the design of experiment, will give you a chart. From that chart, we need to run the experimental work. While running the experimental work, we will get some values, and also it will give you a modeling equation, that is a response, what do you call it, the relationship mathematical models it will give in terms of, it may be a quadratic model, it may be a linear model, it may be a non-linear model, okay, it's a polynomial model and so on and so forth. Okay, so by getting that equation for other types of variables, when you want to within this range, okay, because we have studied different independent variables at a particular three different level, right, middle. So if we change anything, that equation mostly would fit into the things. So we not required actually do the experiment to carry out the responses when you have not when you want to exactly study for that particular independent variables. So meaning to say, you have 16 experiments. In that 16 experiments, the level may be different, okay, the independent variable range will be different, and it will give you a mathematical model. This mathematical model is valid for these three independent variables with that particular range, okay, which has been stated here in the design of experiments. So that rather after we obtain this equation, we don't require to do the experiment, okay, because this mathematical model is valid. So we can use the independent variables within this range, whatever is there, and try to can identify the response. Hope you understood. So, and also while getting the optimized point, we also need to highlight the which factor is more significant. For example, reaction temperature. If the reaction temperature is lower, that will give you higher yield. For example, it's an endothermic process. So if the reaction temperature is higher, the exothermic process, okay, if it is the reaction temperature is endothermic, I mean the reaction is endothermic, that means we need to give a temperature of the reactor in a lower way. If you give higher, what will happen actually? It will not respond. Okay, so endothermic process, it will be absorbed. It will be absorbed. Okay, so exothermic is a, it will be liberated. That you know already. So at what condition the temperature will have a effect on the reaction yield? Okay, that we need to look into the things. Please go and refresh back the things that you have studied. Okay, and coming to the second part, here we are just going to talk about the improving the distillation column efficiency. Okay, so to optimize the separation efficiency of a distillation column for a binary mixture, so you know already separation efficiency can be determined. What are the factors which will affect the separation efficiency? The length of the column, that is the number of trays in the column, the feed temperature which is entering into the distillation column, reflux ratio, that is the L by D. Okay, the amount of distillate which has been sent back, recycled back to the distillation column. Okay, so the amount of liquid L divided by the distillate which has been collected. Okay, so if the reflux ratio increases, obviously what will happen? The number of stages will come down. Okay, so if the reflux ratio is increases and you just keep the number of trays, what will happen? Obviously, the separation efficiency will be more. Higher the reflux ratio, higher the separation efficiency. Lower the number of, higher the number of trays, higher the separation efficiency. So it's directly proportional. What is the effect of feed of temperature? As you increase the temperature, what is happening? It will get easily vaporized. Okay, it's a flat vaporization. Okay, when you have a, for example, I just feed the temperature at a 90 degrees Celsius of water. What will happen? Obviously, the water will become vaporized, right? because it's almost attain the going to attain their saturation temperature. Okay, like that, like methanol. Okay, let's say you have 78 degrees Celsius. In that you just want to send it at 75 degree. What will happen? Obviously, it will get vaporized. Higher the feed temperature, because the distillation is carried out because of the vapor pressure difference. That is a boiling point difference. Okay, so you should understand the behind the basics. That means the engineering principles. Okay, especially the chemical engineering perspective. Okay, then apply the design of experiments. Okay, that will help you to understand more better. Otherwise, if you are not strong in technical, and then there is no point of using a statistical analysis and then try to find out the value. So most of the time, as an engineers, okay, we used to study mathematics, numerical methods, okay, everything in a separate subject. So what I am expecting is that numerical methods for chemical engineers. Okay, so the syllabus is supposed to be in such a way that with a realistic example where you are going to implement in a chemical engineering basics. Unless otherwise, the people will not find it, will find it very difficult to understand the concept how we are going to apply the mathematics which we have been studying, like Newton's absent method, Runge-Kutta method, which has been used for a nonlinear equation, okay, to solve. Okay, how we are going to implement in a chemical engineering perspective, that is very important. That is a lag in our curriculum, in the sense what is called we are not connecting. Okay, the students have been failed to connect, and because the in the lecturing point of view, actually they will cover actually mathematics. Okay, mathematics will teacher will come and cover the things. The chemical engineers chemical engineering subject teachers will cover this part. So it's our duty to correlate these two. Okay, so most of the time we are failed to clear the gate exam because of the understanding of the subject. Okay, that is one thing. The second one, the application where we need to apply what we have learned. That also very important. Okay, please try to understand the concept this. Okay, design of experiments under which we have a full factorial design, blocking, statistical analysis. So full factorial design is used to evaluate the impact of reflex ratio, feed temperature, and the train number on separation efficiency. Blocking is used to eliminate the variability from ambient temperature effect, and statistical analysis is conducted to determine the significant factors. So how much is my significant factor? Just now I told. Okay, let's say the feed temperature is higher, is directly proportional to the efficiency of the distillation column. If the number of days increases, it also directly proportional to the distillation efficiency. And if the what we have seen, other thing is that the number of trays, feed temperature, as well as the reflex ratio. The reflex ratio increases, obviously that will also. So which one will give you a predominant factor? Which one will rank is best? Okay, 5 or 4. All is considered to be same range. And what would be the effect of increase in the reflex ratio on the number of trays? Okay, whether this will vary the things. If you try to reduce the number of trays and then increase the reflex ratio, will not have much effect rather than increasing the two variables. Okay, so you need to think in such a way that what would be the effect of one variable on the other, as well as what would be the response or what will be the effect on the response variable. Okay, hope you understood. So coming to the third example, minimizing the waste in polymerization process. To minimize the waste generation in a polymerization process while maintaining the product quality. So here the three factors they consider as monomer concentration, initiator dosage, and reaction time. So here again the three factors they have taken, three variables, and then three levels has been taken. Okay, coming to the DOE implementation. Okay, so there is a Taguchi method used to identify the most influential factors affecting the waste generation. Replication ensure the reliability of results. Response optimization is performed to minimize the waste while maintaining the product quality. So the best condition identified through the design of experiments for this monomer, polymerization, right? Polymerization reaction, right? So in that 40% is a monomer concentration, 0.4% is initiated dosage, and 4 hours has been found to be best optimum condition by reducing the waste by 15%. So how do they arrive out this one? The system will calculate for you in which variable, which independent variable, and what level. Okay, because we have a low level, middle level, and high level. At what level this will give you an optimized point. Okay, so that's why I told you the contour plot and iso plates, which will help you to visualize the things. Okay, so the example 4 for design of experiments we have already discussed is the optimization of heat exchanger performance. So in heat exchanger performance, what are the factors which we consider to be independent variables? That is the flow rate of hot fluid, baffle spacing and tube diameter. You could not able to reduce the temperature of hot fluid lower than the cold fluid inlet temperature. So that you should be very careful. That's how you're supposed to know, very understand clearly. Okay, otherwise it will be very difficult. So factors which need to be considered are three things. One is flow rate, baffle spacing, and tube diameter. These are three factors and three levels. Okay, one is a low level, middle level, and high level. Design of experiments implementation. A factorial design of experiment approach is used to evaluate the impact of flow rate, baffle spacing, and tube diameter on heat exchanger efficiency. So the heat exchanger efficiency is one of the predominant thing in that particular heat transfer process. Okay, so if you see here, what are the things? No, we will go for actually, if you go for a process modeling and simulation, we will see the shortcut and reverse method and to design the what you call TMA sheet. So the heat exchanger, okay, so if you see what is the number of baffles, what is the inner diameter of the tube, what is the inner diameter of the shell, okay, how many number of tubes supposed to be there, what are the what you call number of passes in the tube side as well as the shell side. Okay, so these are the predominant factors. Okay, why we need to find it out all this, and in terms of chemical engineering, overall heat transfer coefficient, heat transfer area. Okay, and these all factors are very predominant. Okay, so when you understand this concept, okay, then it will be easy to identify and optimize the process. So unless otherwise we have lack in understanding of the process itself, then there is no point of going for the design of experiments and try to do the optimization. Okay, hope you understood what I am trying to say. Okay, randomization ensures that external environmental effects do not bias the results. Response surface methodology helps determine the optimal balance between the heat transfer efficiency and pressure drop. What is the outcome for that? Optimal conditions for heat exchanger performance are a flow rate of 75 liters per minute, baffle spacing of 15 centimeter and tube diameter of 15 centimeter lead to a 20% improvement in heat transfer efficiency. Understand? So all this optimization, what for we are doing? Either we need to try to reduce the resources or reduce the cost or reduce the energy consumption. So that point is considered to be an optimized point. Okay, so you might have studied actually when you come to the final year or most probably in the next semester. Okay, so yeah, now you are in sixth semester, right? So most probably I don't know whether currently you are studying process economics. Okay, so whatever we are studying in engineering perspective, okay, the ultimate aim is to comes to the cost analysis. Okay, so the as a what you call industrialist, when you go and work in the industry, they will ask for a innovation as well as the recent technology may be adapted or even the what you call the implementation of revamping of the present equipment. Obviously they will want to go for a cost reduction. That is very important. So this optimization point will definitely will help you to reduce the resources and reduce the energy consumption. That will lead to a optimized point, that in terms of cost. Okay, coming to the next example, reducing the defect in pharmaceutical tablet manufacturing. So to reduce the defect in tablet production while maintaining the tablet strength, so there are again three factors there coming into picture: compression force, binder concentration, and drying temperature. Okay, so again a three level, and the design of experiments will help you to give you a thing. So when we need to go for which method? We need to go for a one factorial method or a multiple factorial method or Taguchi method or even a RSM or ANOVA analysis of variance. And RSM again you have a D-optimal design, box Benkert method, central composite design. So we have plenty of this. So this is a vast area. Design of experiments, you need to be very strong in mathematics, statistical analysis, as well as and understand the concept of the engineering principles, especially the chemical engineering principles, how we are going to implement and how the optimized point is determined. That is very important. Okay, so design of experiments plays a crucial role in optimizing the chemical engineering processes, improving the efficiency and minimizing the cost. So underline the word minimizing the cost. Okay, improving the efficiency. Please underline that particular words. Okay, so these are the things. So the ultimate aim of to all understanding of all these process principles and everything will leads to a try to identify a point of highly efficient process or means highly efficient output. Okay, that is a product. By systematically studying multiple factors and their interaction, design of experiments enables engineers to make data-driven decisions for process improvement. So, design of experiments is a systematic approach to designing, conducting, and analyzing the control test to understand the relationship between the process variables and their effect on output responses. So, which I've been saying for this starting from the unit 1. Okay, what we are going to do, we are going to find out the relationship between the independent variables and dependent variables. That dependent variable is a response, independent variables that may vary because of the process condition or the process factors. Okay, so when you add this relationship, okay, so then it will be easy to identify the things. Obviously, depend on the process, this equation may be more complex in nature. So for solving the non-linear equation, most of the time chemical engineering equations will be non-linear in form. Mostly it may be a logarithmic or exponential or polynomial or quadratic. Okay, so this equation need to be solved. Okay, so we could not be able to solve by unless otherwise if it is iteration is required, it will be a lengthy process. You might have studied actually in numerical methods or mathematics where you need to go and solve a non-linear equation in a very extensive way. Even it takes quite a long time. Just imagine it's not only one equation of non-linear. We will obtain a multiple equations. So how to solve? Only we use the computation techniques. Okay. So unless otherwise it will be very tedious process for the human to do the process calculation. Okay. So what are the key design of experiment methodology? So factorial design, response surface methodology, Taguchi method. Okay. So these are the things. So when we need to go for this type of methods. Okay. Taguchi method. Use orthogonal arrays. So what is orthogonal array? Orthogonal array is a statistical tool used in Taguchi method and other design of experiment methodology to efficiently study multiple factors with a reduced number of experiments. Underline the word with a reduced number of experiments. Whenever the number of experiments is getting reduced, what does it mean? You can even identify the optimized point by doing a less number of experiments. So the people will go for a Taguchi method in that case. So let's say I will share my experience when I was doing my PhD. Okay, with the spray dryer. The spray dryer actually is actually running the spray dryer is not a tedious process, but at the same time the amount of energy, I mean the time frame which we need to run the spray dryer, cleaning the spray dryer and then again bring back to the normal condition is not easy because the powder particles will be sticking on the surface of the thing. So for running it 3 times per day maybe takes for 9 hours. For one cycle it may take 3 hours. Okay, imagine. So we need to understand the process very clearly. Okay, so minimizing the number of experiments reduce, it will be good for us, right. So structure of orthogonal array which we have discussed already. Okay, so another types of method apart from the Taguchi method are central composite and Box-Behnken method, which I already told you. In Box-Behnken a fewer experiments than central composite design, and when we need to go for de-optimal design. So these are the questions. So you question yourself whenever you try to say when people say something, you question yourself whether what they are saying is correct. Okay, that is a very smart people will do. Okay, so when the people say this is a method which can be help you to give a design of a, why I need to go for this method, why not central composite design? So this is the way the people will question you in gate exams. Okay, so or even if you go for an interview, okay, they will ask the hypothetical questions. Okay, so recently I went for a 2 weeks before I went for an interview where the people asked me a hypothetical question. This has been arranged by the from IIT browser. Okay, then I told them it's a hypothetical question. I could, even if I say something, you will say this is not correct. Other way around. I could not able to justify the things. But however, we can argue. Okay, the argument doesn't make sense. Okay, unless otherwise they accept. We may not be knowing whether they are accepting it or not. Okay, simply why I'm trying to say that is that when the subject has been covered, at the same time how you are going to implement what you have learned in a real life, that is very very important. Okay, so coming to the chemical engineering application, polymer synthesis, environmental engineering. So the benefits of DOE has been mentioned here. Reduces experimental work, effort and cost, identify the key process variables and their interactions, improve process efficiency and product quality, minimize the variability and enhance the robustness. Okay, so what is the benefits is clearly stated here. So please go through the things. Okay, try to reduce the cost and identify the optimized point. Okay, reducing the cost can be attained only by identifying the process condition. Okay, so with this note I would like to conclude the second unit. Okay, if you have any doubt or anything during the face-to-face instruction, please come and knock me. Definitely, I'm ready to help you and support you actually to clarify your doubts. Okay, because this data analytics and machine learning is a new, very new subject. Okay, so this has been arises from after, I can say, after 2021. Okay, so after corona, we can put it in such a way that after corona the machine learning is become popular not only in their own IT field, it has been implemented in different multidisciplinary fields in engineering, especially the chemical engineers. We also can able to adapt this one and try to make use of this machine learning principles and try to identify the process condition, optimize the process condition, reduce the energy consumption, and try to identify the least cost. Okay, so with this note, I just would like to conclude today's section. That means that we have already covered unit 2. Along with that, we also recap the second unit, okay, as two part 1 and part 2. I believe that you don't have any doubt on that. Okay, we will see in next class with unit 3. Thank you for your time. Catch you later.